We're locked in. Gentlemen, lovely to see you all. Everybody, welcome to another live stream. We had a absolute cracker, or should I say even banger, of a stream yesterday, just covering the shared sequencer with David and Capital Garuda. And we're back with another one. There's just so much to unpack. This one is obviously EVM versus AltVM, how the data differs. So we've got Brock from the Indexing Co. We've got James from Pangea. We've got Jason from MVO. And yeah, I think it's going to be one of those juicier ones where the smooth brain like me is going to really ask some dumb questions to tuck in. I do know that each of you guys have some interesting things to share. So yeah, maybe just to kick things off, maybe let's start with James, and then we can go to Jason, and then we can finish with Brock. Just like, who are you guys? Like, I know you guys are working for indexing companies. Why? Like, how did you get into blockchain? Like, what is the background? You can go first, James.
That's a good question. I've been in crypto about 6-7 years, and I came from kind of banking land where, not missing transactions was really important, right? So it wasn't particularly fun to work there, but it was really important not to mess up. So coming into crypto was a bit eye-opening, especially in the earlier days when everything was cowboy, and we were trying to do things, really basic things like how do you measure someone's deposit right into your platform, into your like little trading platform, and even that was a challenge just to keep the nodes running.
Yeah.
But really, yeah, I mean, every project that I've done in crypto had to build indexes for, had to build user experiences, and I built kind of 6 of them alongside Max, and really Pangea is the kind of answer to that question of like, why are we building these custom things? Why aren't there frameworks available? Why can't you just do this easily? Why doesn't the node do this by default, right? So Pangea really came about as an answer to that question, and then kind of over time evolved into what it is now as kind of more kind of comprehensive solution.
Yeah.
But yeah, that's really where it
Walk
started
away from the bank. So there has to be like something that wouldn't like in your brain like this absolutely is dog garbage. Like why did you walk away from the banks and then come into blockchain? What did you see?
For me, it didn't really agree with my kind of personality. I like to help people, and banking kind of punishes you for that because they're a hyper competitive environment and they kind of want to push you in a way. I mean, it helped me a lot learn how to work under high pressure environments, having a production issue where the bank was losing $30 million every few minutes. That's a serious thing. It's a scary place to be and be the one that has to fix it. But at the same time, yeah, the whole environment was just really broken, and it was trying to break me, and I just said no in the end. And yeah, crypto is kind of a good alternative to that. In terms of ethos and in terms of what it's trying to solve, it's like the same problem. So, best case, we apply some pressure to the banks and they get better. Sorry, worst case, but the best case would be, potentially replacing them, etc.
Nice. Yeah, I totally relate to that. I actually I had a small stint, like just after 2019, working in fintech, and going through that whole PCI DSS compliance procedure for like a wallet as a service, and it was just dealing with those types of people is just mentally exhausting. I don't feel like I'm changing the world with those people, so I can relate to that totally. And Jason, I don't think you've ever worked at a bank. Have you worked at a bank?
I've worked at a startup that's trying to work with banks. So yeah, I guess we can somewhat start there. Basically, my first job in crypto was with Consensus at a sub team or spoke that broke away quite early called Adara. Basically, they're doing liquidity management systems, real-time settlement systems, etc., on blockchains for banks. And one of the first projects I did was super cool. It was for the South African Reserve Bank, the SARB. And basically we set up, 9, at the time it was, what is it called? I've actually forgotten the name. It's so long ago. But the enterprise Ethereum client that was big in 2017, 2018. yeah. Anyway, before Bezu and all of those newer things came along, and basically, yeah, we set them up in all of the big banks, and those banks were running Ethereum nodes back at the beginning of 2018, which is pretty cool. So that for
That's
Wayne,
sick.
you're South African. That's ABSA, FNB, Capitec. Yeah, they called the Big Eight, and then the Reserve Bank themselves. And that was a very cool project. Basically, the banks pay each other all the time. I guess that's obvious. But the banks don't want other banks to see what and how much they're paying. It's fine if like
Yeah.
Bank A knows that Bank B paid Bank C, because that's happening all the time. But that had to be shielded. So we also experimented with zero knowledge proofs, which was super fun. So yeah, it was actually a really good time. I think there's a lot of negative energy towards banks in the crypto space, and I don't want to work for a bank for sure. But
Yeah.
there's a lot of innovation that can happen in the banking sector, and to be fair, I think everyone on the call probably uses a bank a lot more than maybe some admit. I know there's those.
But some of the
crazy
South Africa
cloud
banks
bank
are like
accounts.
chats, dude. Like the South African banks
Yeah.
are chats. Like I mean, some of them are pretty progressive. I mean, we don't have to write physical checks to hand them in. I think we scrapped that ages ago. The fact that Amazon still pays people with written checks is wild. So, I mean, besides that, Jason, how did you get into the data piece? Like, where did that story come from? Because I know there was
Long
float
story.
somewhere in between that, you know?
Yeah,
So...
let me not hijack the conversation and sort of get through that. So yeah, I basically realized I wanted to build my own things. I didn't want to work for someone else, and I was a starry-eyed youngster who wanted to change the world. So I definitely did that. And the first project I built was called Wildcards, which was basically a donation platform, and that was the first time I used subgraphs, which is
nice.
pretty cool. So that was
2019.
Yeah, that was.
Wasn't that ETH Cape Town? ETH Cape Town 2019.
That was exactly. So that was mid 2019, just when the graph was like a few months old, which is quite fun. So I was one of the early users of the graph, and it played a massive role. I love GraphQL. I love type systems that fit in with everything we were doing, and I still love that way of building. If I'm to build a UI, and yeah, after that, going through lots of different projects. Every single project we ended up needing an indexer. Big surprise. And almost always we stayed with the graph. The graph at that time just were the best. I tried a few others. The graph were leagues ahead, and basically continued doing that, consulting, etc., until I started a DeFi protocol with two friends, and we started really hitting into the limitations of subgraphs. I think that'll be a whole nother topic, but basically we had to build our own indexer, which is quite fun. It's more challenging than I think people realize when you have to deal with rollbacks, and speed is important. So we had to build something internally.
You guys have given us a bit of gray hair about that. I think like during one of the testnets we had a bit of a rollback, and you guys were down our throats, and I think we put a lot of work on top of you. So I do apologize. And then Brock, just to finish the intros, dude, where in the world are you? Yeah, because I think Jason's in Cape Town, James is in Lisbon, but where in the world are you?
I'm all over the place. Yeah, I'm sitting in Deadwood, South Dakota right now in the U.S.
Sick.
Yeah,
very cool.
I don't know. I'm here for the week. Normally in Dallas, all over as we do. But yeah, no, for me, basically out of college, realized I could make money on a laptop, so I just kept doing it. got bored in like late 2016 and found a job board that I could get paid in Ethereum. I was like, okay.
Dope.
And then, yeah, that company ended up being the first startup that I worked with. So we're doing real estate on chain, ended up running engineering for them for years, did the whole ICO thing. Yeah, been in it ever since. Went to Coinbase, did the loop, and then similar to these guys, coming out of summer of 2022, yeah, wanted to like build my own thing and realized there was no real good solutions out there. Like the graph is terrible, and so you're kind of just stuck building it yourself. And so
Yeah.
figured we'd
Here we are.
take a shot. Yeah.
Yeah, man. That's it seems to be like a lot of the innovation just comes from the struggles that the predecessors basically left for us, and I think it's only fitting. I know it all started at, at least as GraphQL, as Jason mentioned about GraphQL, it kind of all started there, and there's just been progressively better use cases with more demands and requirements around data. And I think, the comparisons between what the EVM, at least in its old state, versus the up and coming AltVMs, the requirements are changing all the time. The technology needs to change with it as well. So maybe just kind of circling this, and you guys can just jump in with your own opinions and obviously agree or disagree, but would love to know how it's changed. So you guys have mentioned GraphQL, that was like the standard. What changed? What made you guys feel like this needed to improve? What did you guys feel needed to improve exactly? And then obviously there's that advantageous move of starting to be the de facto indexing solution on AltVMs as well, which, arguably require different types of data schemes. So would love to hear, if you want to carry on with that, Brock, and then we can switch over to any of the other two. Would love to hear your opinion on how it's evolved.
Yeah. Both a lot and not at all. It's going all the way back to like 2016, 2017. The only way to get reliable data was to go straight to the RPC. So you're just pulling, or at best, if you're lucky and you're working with a better infra, you can get WebSockets. You're still just making RPC calls is the gist. And so you're taking in that raw data, and you have to make sense of it yourself. And as we've kind of evolved through the years, there's more tooling, there's new libraries. Like Web3.js just finally got retired, so that's the thing. But
I saw that.
Yeah, I know. Yeah, but we've moved through time, and as we get to the AltVMs, I think we've learned more about how to make the data usable from day one. So a lot of the early issues were that the data is stored basically compressed, encoded. It's meant for cheap storage, not for usage. I think we're starting to flip that around a little bit. Yeah, I don't know. There's a lot there.
I was going to say it's like a mixed bag. Like I actually think that a lot of the AltVM stuff has actually gotten worse. I mean,
very true. Yeah,
just say that, dude. What do you mean? Just say that. This is a fuel stream, and you're saying it's gone worse. What do you mean?
Well, UTXOs are a pain in the ass, right? So all the benefits are great because you're shifting like computation to client side, especially with things like predicates, right? You can do your 400K TPS, but there's a cost to that, right? Which is non-trivial in terms of how you actually build the thing outside of the chain. So I think that because basically you can't actually solve, high TPS in like one place at one time, but all you can do really is move the problem around, right? So either you don't synchronize, so you have like one leader, or you like shift off the computation to the user, so they have to prove and then send back the proof, so you reduce your scope of what the leader needs to care about. So there's all sorts of these like trade-offs, and where trade-offs change, the data changes, and like, we're looking at predicates, like, the best possible ways we can index them. That's one example. But yeah, really those data formats, the methodology of the chains changing, I think has a huge impact on indexes and our abilities to deliver user experience to a customer, like at all in some cases.
Yeah, I also think if you look at how things have evolved, just the way we sort of measure the speed of an indexer has changed. I think when there was only Ethereum in town and you were one small app with, Ethereum's 13-second block times and however many transactions per second, things were a lot easier. And up until very recently, I was still seeing other indexes speaking about their speed in terms of blocks per second, which is kind of abstract, and I think it's like a remnants of syncing from an RPC. As like when you sync from an RPC, you're like scanning blocks individually, and it is super slow. Whereas a modern indexer, it really is more about events per second. So you could have a very sparse app with very few events, but like millions of blocks, and it should be lightning fast, and you can have a very heavy app with lots of events each block, and the number of events per second should be similar. So I think that's something that's evolved, and that's
what examples between like what an event heavy app is versus one that isn't, like just so that the users can understand that from a basic point of view. Yeah, you're on mute there, Jason.
Oh, that was silly. There's so many examples. I think most stable coins, for example, have a lot of transactions every block. Uniswap, obviously it depends on the pool, but the popular Uniswap pools are having lots of events every single block. You can see the price changing and people doing arbitrage within the block. And then, I don't know, like probably the trading of what's it called, CryptoPunks. You know, I wouldn't know the exact numbers, but probably a CryptoPunk is sold every several hours. Probably not that much faster than that. So yeah, it really does depend. And I think when you're building your app and working on the testnet, I think people often get in the trap of, oh, it works on testnet. Cool, I've tested 50 transactions. Wow, everything's perfect. They launch their DEX or their sort of more high throughput app and realize that things break as soon as they have more than a few hundred users, which definitely is a modest goal for any app. So yeah, it's really important to think about performance from the get-go. And I think with AltVMs coming out like fuel, we hopefully will start to see a lot more even higher performance apps.
I just wanted to add there, like this is something that we've seen a lot of, where apps get themselves into a real bad state, like they end up with this Frankenstein dApp where they have RPC, something like the graph, and their own indexer all in the same app at the same time. They're all out of sync, different latencies. You know, you click one button, that one's not ready, so you go over there, then it's checking RPC to make sure actually you can do that now and it's the right price. And you know, that's one of the reasons that we've really looked to replace all of those things together, like RPC as well, so that you don't need that as part of your stack, because of these exact issues that Jason's mentioning of like people not considering from day zero their scaling and their issues, and then trying to bolt things together to actually make it work at the end, which, you know, you don't want to be doing that under pressure, under growth. You want to do that before.
Yeah. Maybe just for the audience, can you just give like the Eli 5 on the difference between the indexing that you mentioned and what an RPC does, like how each of them serve that function and why it's important to differ?
Yeah, sure. So RPC is really designed as something that's completely general. So it can do kind of anything, which is great for developers and for integration things, but it can't do everything well, right? So the nature of RPC means that you can access kind of any point on the chain, but not necessarily that fast. And it kind of suffers with things like history. So for you to be able to say, hey, what have I got now? It's more or less okay, as long as you've got only a couple of tokens. That's 2 calls. It's reasonable. But then if you want to go backwards through history, maybe say what you had yesterday, then it becomes a lot more difficult. And also, we've just done an RPC provider review of like 50 providers, basically the top 50, and only like 2 of them actually perform well. So, well means within about 10 to 15 blocks of head, and how like basically keeping within 10 blocks of head for over a week, which
Okay.
pretty much none of them do. So they're basically atrocious. And we're producing a full report on this because it's such a serious issue. And something that we mitigate, we connect to many, many RPCs and our own nodes and validator nodes as well that we partner with to make sure that we don't ever have any delays like this. But that's another really big issue with RPC that I think is not clear to new people coming in the space, that if you're not willing to host your own nodes or really negotiate with, these enterprise providers and get dedicated nodes and really negotiate and make sure they care about you, right? Have that supply relationship. You're going to be kind of not in a good place, basically, as a project. And I was really surprised at this. I can't actually believe how badly a lot of RPC providers score.
It's a banker coming in here and just shitting on crypto. But it's a valid response. I think it's the people that don't care need the wake up call. And I suppose this new approach that indexes are coming in with will probably shake that up. I think there's been chatter about just getting rid of RPCs altogether. Is that something that the indexing company is also looking into, Brock, or like how are you guys approaching this?
Yeah, I was trying not to jump in, but we have a slightly different view where we assume that the RPCs will always sort of suck, and we just want to meet them where they're at. So we do a lot of work internally, trying to load balance against it, treating it block by block because that's how the RPC handles it, and really just trying to, I don't know, onboard the mass of potential RPC services versus I don't know, expecting any particular one to be performant. Yeah.
Yeah. So maybe just to kind of like get into the thick of this, right? So indexing company, Pangea, MVO, would love to know the differences in your approach. Like James, I know you guys come from indexing the hell out of Bitcoin. You guys are very familiar with UTXOs. Jason, Ethereum built an instance on Fuel to index Fuel. There was obviously different challenges there, but you guys largely adopted the product that you built on the EVM to Fuel to work. And then obviously Brock indexing code, would love to know the approach in general. So what makes you guys different? Because you guys are all solving the same problem, but with a creative approach. So yeah, would love to know.
Cool. I'm happy to start. I think the sort of challenges that we've spoken about are speed. So there's kind of two types of speed. One is head lag. That's latency. Like when an action happens, how soon does it show up, which is super important. And then the other type of speed, which becomes super important when your app is large, is historical speed. How fast can you resync everything? And we basically realized that you can build the best indexer in the sort of traditional sense, a replacement for a subgraph or something similar. But if you still use an RPC in that process, your indexer will basically suck because you can't do better than an RPC. Like the only way around it is to have extremely high bandwidth, like really good internet, and have an RPC provider that allows you to hammer them super hard. And even then it still sucks. You're like parsing JSON objects and receiving these bloated strings from the RPC. And you're getting a lot of data you don't care about. But basically, RPC is great because it's standardized, but it's not great for indexing. So the approach we went is to build our own node that is an indexer itself. It indexes every single thing on the chain.
Like a specialized node.
It's basically like blockchain nodes are very good at execution and consensus. It obviously depends, but they specialize for that. They are not good databases. They are not good at retrieving data and serving that data. Yet we put a lot of pressure on them to do that. So what we've built is a non-execution, non-consensus node that has all the data. and you can then create filters on top of this node. It's called hypersync, and get all the data downloaded in a binary format, which saves a lot of bandwidth, is way faster, literally more than 100 times faster than querying the RPC. So that's the sort of top approach. And then on top of that,
Yeah.
we've built something very familiar, which we've called hyperindex. Sorry, it's familiar to a subgraph. So you write handlers, generate the GraphQL interface. If you've written subgraphs before, you'll feel literally at home, almost the exact same sort of thing. So yeah, that's the kind of overview. I'd rather not comment on others' projects. So yeah, let me hand over to James.
James, I think you have a soft spot for GraphQL, don't you?
Yeah, love it, love it. Yeah, like that aside, like in terms of the approach, some things are actually quite similar, right? So, you know, nodes are really bad at reading, right? They're designed for writing. They're not, consensus execution. So yeah, in a lot of ways, we take a similar approach. Our users are completely isolated from RPC, from nodes, etc. We do modify our own nodes as well across the chains that we support. And then we tend to run with validators to make sure that we have the lowest possible latency. Our customers are super sensitive to that because they could be front run. A lot of exchanges, etc. We need to make sure that their users have the similar experience to market makers and have access to the fastest possible data. So we tend to get transactions before they would even be available on an RPC of a similar node, which is pretty nice. So our customers basically beat RPC, which is kind of hilarious because it should be not possible to do that, but it is. But in terms of like how our customers then interact, and this is where we significantly deviate from something like MVO, where you're building it yourself with the GraphQL kind of engines, where we're really looking to kind of set a new standard. So we have our own DSL that we're testing with a few choice customers at the moment. It's kind of looks like SQL, but doesn't. It's our own execution engine. So we have our own database that we built from scratch or in streaming engine. We don't use anything off the shelf. And so that just lets us really deliver performance that's quite different. So in Fuel, for example, we index at like 500,000 transactions a second. We'll be increasing that soon. I think it's equivalent to like 1 to 2 million events a second. And that's scalable across different protocols. So you can do that on every protocol that we index. So it's quite a different.
Just for the audience, what's the difference between the transaction and the event, just so that they can understand that?
Yeah, so I really like Jason's kind of idea, like you should measure events, not transactions. Although we have migrated from blocks per second, we have only got so far as transactions per second in terms of the status quo, where these kind of high TPS, they're called high TPS EVM chains like Megaeth or Monad or whatever. They're measuring TPS, not events. So one transaction could produce many events. These are things that indexes usually care about. The other thing that indexes care about is things like state, which is stuff that's not in events, which actually in Fuel is quite a bit easier than in Ethereum, which is kind of fun because if the assets live outside of the contracts for the most part, so you don't have to worry so much about trying to acquire a specific storage slot that's been referenced at a specific time and then grabbing that out of the data store. So.
Nice. That makes sense. Nice save because of the earlier comment. I'll call us even. And Brock, indexing code, like, do you kind of resonate with that approach? Do you guys take like a middle ground between MVO and Pancha? Like, what's the secret sauce?
I think we're kind of the black swan of the whole industry. So we have no database is the short answer. So there's no database in between the entire thing. We found it really expensive and really slow. And like you spend all your time trying to fight the database. So we just decided to eliminate it. So instead we go direct to customers and we rely on distributed compute. So when a customer wants, say, transactions on Fuel or whatever it might be, we'll do a parallel process and deliver that directly to their database. So they get it in their environment from day one. And yeah, it's let us really reduce latency, and we can do backfills basically as fast as they can receive it. So the only limitations on the customer at that point.
That's pretty wild. What teams, in your opinion, have locked into that and benefited? Like, it can be from any project ecosystem.
Yeah.
Like, just want to understand the use case.
Yeah. I mean, we're seeing it across the board, but a lot of current verticals cover things like DeFi. So Solana's been a big mover just kind of in the market right now. We do Solana data.
Yeah.
We might be the only ones that can go to Genesis. So we have everything. We can dump it in databases for customers. So like we did a backfill for all DEX swaps on Solana. I'm just
Nice.
straight into Postgres, fully optimized for them. Yeah. And then, yeah, other use cases. I mean, you have the classic like DApp protocol. I've got a project. I've got users. Those users have wallets. They do transactions. I want to know about it. So we can do all that as well. Yeah. I don't know. For us, it's if it's on chain, we can get it basically.
I do have a question. So you say you don't have your own database, but you do store the data, right? Like you have all of the Solana data or whatever chain's data. Is that not in a database?
Correct. Yeah. So we're doing. I mean, I'm sure we're all caching at some level, but for us, we're taking it. Take the raw data from an RPC and we throw it in blob storage. So we just compress it. Yeah.
Cool. Interesting.
Do you go, Jason?
A little bit off topic. I'm kind of curious because I've heard from different people how difficult it is to run Solana nodes, and I've heard it's impossible to run a Solana node from Genesis. So yeah, I'm definitely curious, and I definitely think this is a shill on Fuel because I'm pretty sure forever it'll be possible to run a Fuel node from Genesis or Ignition node from Genesis. So I'm just curious about that.
It was a thing. Yeah. So we definitely cached it. So we have it.
It was a thing.
Yeah. No, it took us. So for the audience, Solana data, I think it gets dropped off of nodes after 3 or 7 days. Basically, there's no historical state available over an RPC. So there's a few providers out there that claim to have archival nodes in some form, but the official archival state lives in a BigQuery database. So it's just hosted on Google. So long story short, we managed to load balance across 4 different RPC providers to go get all the archival data. And we just kind of like let our infrastructure fan out to support whatever they could give us.
That's amazing.
Wild.
Yeah. Yeah. But yeah, this is why we do everything by block so that we can match just the raw RPC data and not pre-process anything. So we just have it in the raw form and we can process it on the fly.
That's very nice. Yeah, we also looked at Solana. It's like,
yeah,
it's going to pay us enough money to store 600 terabytes of crap. So I was like, no, do this later. So you guys have already done it. This is awesome.
Yeah, no, similar. It's we've mostly stuck to EVM chains, and it's not because we maxis, because we pragmatists.
I'll claim to be an ETH maxi still, but no, we support it all.
That's insane. So maybe just to spend like the last 20 minutes, I would love for each one of you, if you're ready, just to kind of run through how quickly it is to set up an indexer. If you guys are able to go into your docs, run through something, show people how easy it is to just start indexing something, or even just going through the docs and explaining it. We'd just love to see the flow and what it requires. I think most of the people watching would love to see that. So who would like to go first?
I'll take a request. If someone can send me a contract address, I'll index it.
Should we do something simple on Ethereum mainnet, and then we can go a little bit more complicated and do something on Fuel?
Sounds good. Yeah, I mean, it can have lots of events, but maybe not a full like Uniswap USDC ETH or something. Just for
let's see if we can dig something
for sake of time.
While we're all doing that, Jason, do you want to maybe just talk about what John made the other day, just around how he was managing to track the deviation between oracles? I think it was like Oracle Wars that he created. I think that was like super interesting.
That is a fun project. So Basically, you know, with our background in DeFi, we had to deal with oracles, and it's always been interesting because the price that comes from an oracle can have a huge impact of what happens on chain. Things can get liquidated. If an oracle is incorrect and someone is able to get that price, they might be able to make a big profit via some kind of arbitrage. So yeah, my co-founder John spun up an indexer, initially just looking at Chainlink and Redstone.
Yeah.
And it's really interesting seeing how much they deviate, especially in times of volatility. So I think there's going to be a lot of back and forth between RPC providers. Yeah, basically, sorry, not RPC providers, Oracle providers.
Yeah.
Basically, like, once the data is a little bit easier to see, I think you know, you can actually see which oracle is better. So yeah, it's a very fun project. You know, there's L2 Beat. It's kind of like L2 Oracle. Sorry, Oracle Beat.
Oracle Beat. It was like Oracle Wars.xyz, right?
Yeah, it's Oracle Wars.xyz. Yeah. Yeah. Okay. If no one's giving a contract, let's look for CryptoPunks or something.
Well, here we go. Ran an NFT project that Brock did a couple of years back as a contract address. Yeah, it's in the chat.
Cool.
Random. Yeah.
Sorry to the peeps. I can't see this. I'm assuming this is on mainnet.
Yes. Yes. Sorry.
Okay. Share screen. Permissions. Blah blah blah. Okay. Closing all my illicit content. No, just. Okay, so let's do npx. Sorry, npx nvo init. Yeah.
Are you sharing your screen?
Oh, can you see my screen? Is it too small? I'm sure it's too small. Can you see in the top left corner?
Maybe you can try zoom in a bit.
Still, okay.
Even more.
I've got a really big screen, guys.
There we go.
Okay, cool. Let's call this random NFT. Let's use TypeScript because that's what people like. We should have done a fuel contract in hindsight, but sorry, this is EVM. We'll do contract imports from Ethereum mainnet, paste in the address. And here we've got all the events. We'll grab all of them. So I'll press enter. We can actually add more addresses, but for now this is good. Let's skip the API token for the demo. Sorry, just it'll work without the API token for now. And this generates an indexer for you. So what is it? Random NFT projects. You can see all of the stuff. Let's do the event handlers. Okay, it's called Hot Dog Time Machine. And then we can do PNPM start. Sorry, PNPM dev. And this will spin up an indexer. Okay, it's starting up Docker. Okay, that's a bit awkward. Let's get Docker running.
What's Docker used for? Is it for the database?
Yeah, so we actually don't need Docker. It's just for convenience. So we've got Postgres and then Hasura, which is the sort of GraphQL layer. So let's check. Nice. Okay. It's normally a lot faster because I actually have these things. So the demo gods are getting me. So now it's just using my internet, pulling the images. Okay, that's unfortunate. Won't be long. So once that's done, it'll pull all the events and index it. Let's quickly take a look. Etherscan.
Yeah, there shouldn't be that much.
Sorry, address.
Did this NFT project go to the moon, Brock?
Definitely not. No. We just did it for fun with some friends, and then a bot found it. So a bot bought them all. I was like, okay.
Amazing.
Yeah.
Magic
yeah,
into their money.
Exactly.
It'll run through all of these and create the GraphQL API, which you can then edit and modify and do whatever you want with, which is super fun. Yeah, sorry guys, I was actually messing with my Docker. Long story. There we go. Docker's becoming available, and yeah, now it's started. So it'll track the tables and then start indexing. So you can see here in real time, it'll fetch all the data.
It's a nice touch with the MVO.
I know. I like that.
It is taking a while. I'm not
Obviously, the growth guy is just paying attention to the branding.
Yeah, really interesting that it hasn't fetched data yet. There we go.
Nice.
Cool, there we go, all synced. And the password is testing. So yeah, here you go. Here's all the data. If you want to look at the approvals, let's do, okay, that's specific approvals. Yeah, let's just grab those. Run that. Okay, there's no approvals. Strange. There we go. Yeah, it can't be a very popular NFT project. No one's approved their tokens.
Yeah, no.
It's not being used to DeFi.
For it to be a small subset, there's not much there. Yeah.
That's amazing.
But yeah, this is the indexer. Not the smoothest
That's huge.
demo I've ever given, but
Well, I saw the Monad Haha app indexing video go around on Twitter, and that was blatantly quick. So demo gods were against you today, but that video was great. So definitely bullish on MVO. James, do you want to try the mirror contract that I shared here in the chat? Do you want to give that a whirl?
So we work a little bit differently than MVO. So we tend to work with customers kind of to build their data sets because we bring all of them into Pangea. So we have at the moment we have a little bit of takes about an hour to kind of write the code for a new contract. But I can just show you like one of our examples from one of our customers. So I was trying to find the share screen buttons. So basically, you should be able to see now. It's a very white and very small screen. It should be. Can you see that okay now?
I can't see anything.
Well, I am sharing. Let me try again. Exciting, isn't it, technology? How about now?
We're in tech, but we hate it. Because it never works for us.
That's
Cool,
right.
there you go.
Yeah.
There we go.
So
Zoom in there for us if you can.
yes, Mac likes to try and help me with this. There we go.
Yeah, that's good. That's good.
So, you know, we basically have a whole bunch of like custom examples. So these guys actually are an intent solver, so they need like really low latency across chains. So this is from Fuel, and you can see like this is all their deposits. And yeah, so basically it just pulls them pretty much immediately for the whole history. These guys only have like a few hundred deposits in their chain, but they pop through all fully decoded. So you can either use this in your own database, or we can also build up we call them toolboxes, but they're kind of similar, like data processors, and build those into ourselves. So we have like more strongly typed data, like for Hashcase, where they want to get their swaps from their DEX, which is a mirror fork, basically, their DEX.
Yeah.
So this is obviously more typed and comes ready to use for those users straight away, basically. So it's a little demo. I'm not so confident as Jason to go from scratch online in real time. We're definitely not set up for that. We're set up more like enterprisey, like come talk to us, and we'll do exactly what you want with you, but you have not as much freedom, which is sad. And we will fix it. In Q3, we'll release this customization factor, so we'll have people be able to do everything themselves. Which is great.
I think there's value in both approaches. I really do. You guys are obviously trying to lock in the best use case possible to showcase the indexer, whereas Jason's taking on, or at least MVO is taking on, something that's just very easy for somebody to just get up and go. There's value in both of those approaches. So,
well, yeah. I'll be honest, like I'm pretty jealous of MVO's approach. I think it's great. I think like freeing people to go and onboard themselves is really, really powerful. And that's why we're also going to take that approach. We're just have to be pragmatic about getting out to customers as early as possible, and we build that ourselves in this case. Okay, it's quick for us, but we can't open up that language. There's still lots of work to do on that, basically, prior to releasing it.
Yeah, nice. Brock, are you ready? Are you on the spot?
Yeah, let's do it. Yeah, here we go. All right. So normally we do all this. I don't know. You can do it over APIs. You can do a bunch of different ways to interact with our platform. But that's kind of our demo playground, if you will. So if you're ready to that. So yeah, the way we work, again, we have like 110 blockchains at this point. You can get all the data raw, you can process it. And so a lot of what we're doing, if we click into any of these, you get the raw data instantly. This is the latest block. And then you get code. So you can just write JavaScript to transform all of this. So we could say, hey, I want ERC20 transfers, apply the template. It's nothing in an ape chain, so we could go over to, I don't know, it's probably more an abstract. There you go. So now there's data in abstract. You can try to see how you can switch between chains that way.
Yeah.
All of this. Yep. And all of this is just code. So we could be like, hey, we don't care about token anymore. Now we don't have token in the output. And then all of this can go webhook, database. You can get it over an API. Yeah, try to keep it really simple. Let customers just take the data.
Lean.
Yeah.
Very lean. Wow.
Yeah.
Wow.
It's awesome.
And how long has indexing code been around? Like,
yeah, we've been in business a little over 2 years now. Most of it was just kind of R&D, trying to prove out that we can do this without a database. And now that we can, we're starting to build out these interfaces to let customers interact with it directly.
That's amazing.
Yeah.
Cool. Well, guys, I really appreciate the demo. That was insane. Did you want to say something, Jason?
I was going to ask. Oh, sorry, Jason. Please.
Go for
Both. Go for it.
Okay.
You, me. Yeah, Brock. I'm quite curious. In that JavaScript, obviously, you have to like have the right structure for Ethereum. Like how different is it for? I'm assuming you have Fuel Data and Solana. I don't know what else you have.
Yeah.
Is it like a different JavaScript library, or is that same library kind of just modified slightly?
It'll be the same library. The underlying data is obviously very different. So like if we were to pop over, try to do one more tiny demo. So if we look at, like, here's a Solana block of data. It's meaty. This is probably too zoomed out, but you have things like headers, you have accounts. It's very different data. If you go look at, say, Ethereum, I don't know what block we're at now.
Can you do aggregation within like the pipes? So can you say, because for Solana, like the pain in the ass is like a user's balance is a composite of all previous transactions, right?
Well, so the beauty in Solana, I wish this was not so zoomed out, but the beauty in Solana is the balances for a user are included in every block. So every time there's a transaction or a transfer, that's included. So you don't actually have to compute the previous transfers, you just get it in real time.
Okay, got it. But you still have to compute the diffs or the delta between the balances or not?
Yes, but they're given to you. So that's where that job starts.
Okay.
Yeah. So you can
nice.
you free in the post transaction balances and then you can diff them. Yep.
Nice. That makes life easier.
Yeah.
I mean, this is actually, you wanted to ask about AltVMs earlier, right? This is like one of the things that Ethereum is awful at, is balances, which is kind of hilarious. It's like the only use case.
When we're all looking at log events for balances on Ethereum, but then you can still update a balance without emitting a log.
Yeah, so we don't, that's one of the things we don't do. So because we have wallets as our customers, we can't do that. So we use state and we have like our own VMs and stuff to do that, which has been a pain, but we're there now. So it really helps with like these high TPS chains as well, because their RPCs don't have state. In fact, actually nothing has state. So already people are realizing that like Monad doesn't have historical state. So if you want to know what your balance was, you're buggered. So it's exciting times for high TPS chains, deleting everything.
Then there's the problem of native asset versus ERC20, which is also awful. So yeah, a fun fact, if you want to use this is why RPC sucks. If you want to calculate the history of ETH transfers of an address, you have to run trace RPC calls on every single block to know for a single address what changed, because the ETH transfer does not omit those logs. So yeah, basically good luck if you want to do analytics on native assets in the EVM ecosystem if you don't have a good indexer.
Yeah, I mean the funny thing is as well, like the forks in like the OpenSea code, where it's like if ETH, and it's completely different code paths. It's hilarious because it's like totally different. So it's mental. Yeah. Well, good thing we've got things like Fuel, where native assets pervade, right? So we don't need to worry about any of these things anymore.
Explain that for the normie. Like why is native assets on Fuel like somewhat of like an advancement here?
It's a separation of concern. So computer science, we like to see things where they should be. So you have state for contracts, so they can record things that they need for that contract specifically. But instead of you in Ethereum, like a contract stores your tokens. So like the ERC20 contract for USDC, that actually owns your tokens, and you through that contract have a right to move them within that contract. So you can transfer it by effectively taking away a number from one slot and adding it to another slot. So that's the simple kind of way it does on Ethereum. But on Fuel, the contract defines the rules for how an asset is moved, but the actual asset itself is stored underneath your user, which is kind of more sensible if you think about like conceptually cash in your wallet as a equivalency. It makes more sense to do that. And quite a few of the modern chains do that. Fuel is interesting because it does it through UTXOs, which has obviously enabled you guys to do more interesting things with like predicates, etc. But other chains also do this and have asset-based transfers, and it just makes more sense for both indexers and for users as well. Although I will tell you a funny story about Sui super briefly, which is Sui's validator rewards when you are staked come as an NFT. So if you just leave your stuff staked, you end up with tens of thousands of NFTs, which are actually impossible for any wallet to use. So definitely things for Fuel to look at is what happens if a user creates 20,000 UTXOs, right? How are you going to handle that? How does the chain react? How does the indexer react? How's the wallet react to signing all of those? It's going to be hilarious.
Is it going to be hilarious, or are you just being sarcastic?
Oh no, it's going to be fun. It's going to be fun to watch like someone's mobile phone attempt to like sign. Like I've come from Bitcoin, right? And you know, someone wrote on the Bitcoin chain like Kanye West for president 200,000 times in one transaction for every single V out in an op return. And I'm like, what are you doing? Like, but these things happen, right? And Fuel's going to encounter all this fun stuff too. So
can't wait. It's going to be hilarious.
I think Fuel is interesting though, because I might get the specific details wrong, but it's UTXO based except inside contracts. So the contracts actually do have a balance, which I think kind of makes things a little bit better. Just thought I'd throw that out there, because that could get messy.
They can own assets, right? Contracts can have assets. Yeah. No, that is true. It's good.
Well, gentlemen, we've hit time. This has been like an awesome live stream. I think before we call it a day, it would be nice if you guys just did like a shameless plug, where you guys are, where you're expanding to, what you're up to, and then we can close this out. Let's go with you, Brock.
Yeah, come find me, indexing.co. Keep it real simple on Twitter, Telegram, wherever. Yeah, we got 115 chains, something. If you need more data, let us know. We'll pipe it direct to you.
Yeah, appreciate you joining, dude. James, where are you guys going in the world at the moment?
Yeah, so you can find us at Pangea.foundation or at @in_Pangea on Twitter. What's coming soon in the Fuel ecosystem, two big things. One is native balances. So this is full history of all of your token movements as asset balances. And also pricing based on all of the dexes on Fuel. So native pricing for native Fuel tokens, as well as Ethereum-based tokens and stuff as well for stuff that's bridged. This is really important for like some tokens that have low liquidity on Fuel, or there's a price differential, for example, between Fuel and Ethereum. So those two are coming soon and are integrating with some of the wallets on Fuel. So really excited about that, because the more key infrastructure we power, the happier we are. So.
Amazing. Thanks for joining, dude. Jason.
Yeah. So definitely come check out our docs, docs.nvo.dev, our website. We've got a hosted service. /fuel. We've got a hosted service. So if you're building on Fuel, especially, or any EVM chain, check it out. We multi-chain, so if your app is on Fuel and 5 other EVMs, we can sort you out with a single indexer for all of that, which is definitely unique. And we are blazing fast. Nothing beats hypersync, and I really stand by nothing. I have not seen anything able to ship data and filter data faster than hypersync. So that's
amazing.
That's my plug. Come check us out.
You guys are doing amazing things. Thanks for building on Fuel. Thanks for doing the things that you do on Fuel. And we'll catch you in the next one. Cheers, everybody.
Thanks. Bye.